Hello everyone, welcome to another stream. How's it going? So today we're going to be working on making the the map generation more parallelized. So currently we have a sort of map gen, which sort of generates and views it generate at the same time. We'll probably have to remove that. This does cause some bugs. But yeah, currently it is parallel, except for when it tries to make this big old voxel map. Well, it's not that big, to be fair. I want to make it bigger. It ends up doing it in a single-threaded way. So we go into we look for the jobs. There's two jobs. There is a, let's disable that. There is a job which generates it per chunk. So currently we just got a chunk being 256 cubed. And this is meant to be the code which decides if a voxel exists or if it doesn't, and also what material it uses, right? So we just got a very simple sine wave, so we get hills and valleys. And we'll make this better later on. So this happens, there's 8 different chunks that can be going at the same time. We might want to make that configurable, to be honest, or at least scale to the number of CPU cores that you have. And these all run in parallel, which is great. They get their own bit of distinct memory, a game map chunk. And yeah, it just generates into its own little array, so it's completely multi-threaded. It's just a 3D array of voxels. Now this map is 512 cubed, whereas the chunk is 256 cubed. Ideally, we obviously want to make the map bigger, but we're just testing this out at the moment. Now, the other job takes those chunks and one at a time, right, this job launches single-threaded. It builds a voxel model. Somewhere here. Yeah, it builds it here. So it builds that voxel model in a single-threaded way. Now, this is problematic because it means that obviously this is the slowest piece of code at the moment. And we have, oh hey there, Streetfire, welcome. How's it going? Yeah, not bad, thank you. I'll answer that in just a minute. But yeah, so this has this has a problem where the slowest piece of code, where it goes through the whole map and tries to store inside this hierarchy of nodes, it just takes it takes a lot of time to do it. So when the game starts up, you see in this 4x4x4 sparse tree that a lot of this time that you see here when it boots up is literally because it's trying to store those voxels inside the map, and then I think has to upload them as well. And I'm pretty sure it's the storing code and not the upload code. From my previous tests, I'm pretty sure that's the problem. But I've thought of a way to actually make this parallel. So rather than us taking the chunks and then taking the chunks and put them into one big model, what we should instead do is make a model per chunk and then stitch the tree together at the base of the tree, basically. So we have let's draw it in Milton, I guess. If we have a 4x4x4, where each one of these tiles obviously represents a chunk. These can all run in parallel, making their own little map model. And when they're all done, we can have another thread which comes by later on, which basically takes all of those subtrees and then patches them into just another layer, another node above it. So it's just one extra allocation basically, which is really quick. And then just stitching pointers to those basically. So it should be quite easy. So that's what we want to work on today. And if we can get that done, that'll be a massive improvement for the map generation code. And there's only a small amount of stuff left to do from there till we can actually start doing something proper. Yeah, everything's going good. Yeah, things going good. I took my wife out yesterday for her birthday. I'm off for 4 days for work now because I don't work Fridays and it's bank holiday Monday. And next week is the last week before the baby comes. So, yeah. Just a little bit tired at the moment. Other than that, all good. I don't understand why it's faster. What's the difference besides just being done in parallel? Why is it stitching together better? So the issue is so this one's already done in parallel, this chunk generation job, where it generates the chunks in parallel, right? So this is a linear array of voxel data 256. The issue with this is it's got air voxels. If it's got air voxels, it doesn't save space because it's not a tree. It's just a linear array of voxels. So what we want to do is turn that into a model. So this is a 512 by 512 map. And so later on, we launch one job, which goes over all the chunks which have done, and it basically tries to take all that chunk memory and store it into a voxel into this final voxel model. The issue is my voxel model APIs it's only thread safe when you target a model on each thread. So it's not thread safe if you want to target the same model on many threads, because it's modifying a tree as it descends down. So this is why we need to have a model per chunk, and therefore it work per thread, and then we can stitch it together in a later thread, and that'll be super quick. Versus trying to take it'll be 8. So 256 times 256 times 256. So it's doing currently 16 million operations per chunk. So we've got 8 different chunks, and it's doing all of that single threadedly. Whereas it could have just done it in parallel and then done the 16 million on each individual thread and then just stitch it together. Make visualization, don't mind. So it's linear, does that mean now what I mean by linear is that it's just an array. Right. So what's a way of thinking about it? So it's like an image file. Right, linear is an image file or as a texture file, right? Where every pixel is a voxel. There's a 3D image, right? So that's how the chunks are made, right? They're literally just, here's an array of voxels, and we're just storing in there, basically, right? It's more on swizzle, but yeah, it's basically like a texture. So it's not a tree. Whereas if you see here, this model which we render is a tree, meaning that it's a 4x4x4 set of nodes. If you see here, it's got some of the nodes when I put the mouse over, they don't get traversed. I need to do the other visualization. So they get missed. They're completely empty. Completely empty, which means they don't store any nodes. At the there's no memory used for voxels in these empty node areas where there isn't any data. And this is what we've got to try to insert it into. Do you sort of understand what I'm saying? So currently, we've got to move with the chunk. We've got to give it a voxel model. And we've got to we're trying to cut down on the amount of things that are required to be done in a one thread. Yep. You can split 12 tasks along each thread hypothetically. Yep. And that would speed up the total time required to generate everything. So you can stitch everything together at the end. Yeah, exactly. So currently the chunk generation is multi-threaded, right? It's happening in parallel. So there's 8 of them that happen in parallel. The issue is when they're done, it takes that array and then it tries in a single threaded way, right? It pops off the next chunk and tries to store it into that tree, right? Goes to the next chunk, tries to store into that tree. So this takes a lot of time. And so this is so we can parallelize this part. So it happens along with the map generation, puts it into a Voxel model tree. And then this thread instead can just allocate one new node and then set 64 different values to point to the chunk models that were made and then delete the old models basically. And that should make it even more parallel. You'll have to traverse along the array anyway. But it has to traverse over the whole array and then try and traverse down the whole tree every time. If it's trying to set an air voxel, there is some optimizations where it only descends so far down. But yeah, when you're trying to store new nodes, it has to keep descending down the tree again and again and again. There are some optimizations I've got this voxel accessor where it sort of remembers the last set of nodes it was down, so there'll be a lot of sharing. So you recently set a voxel there and tried to set another one here. It will basically remember, and it will remember like this hierarchy. So you see the hierarchy of the nodes. You got a child inside of a child inside of a child, and the voxel's the most leaf one. Well, it already knows that hierarchy, so it just checks, right, is my coordinate inside this the bounds for this leaf node? And it says yes, so then therefore it's just able just to set it right away. But as soon as you go out, it's got to traverse back up and then traverse back down. So, and it isn't always that efficient because sometimes it does it in Morton Z curve order. It might have to pop out 1 or 2 or even 3 layers, but very rarely. But this accessor saves a whole ton. It's pretty good. Right, so I think what we can do is always first start praying, obviously. Father in heaven, we thank you, Lord, for this day. We bless your holy name. We thank you for providing us everything we have. The food on our table, the cars on our drive, the spouses that we have. Lord, we just pray for your mercy and forgiveness where we sinned against you, Lord God, and we just pray for your guidance, your spirit of counsel, your spirit of wisdom, your spirit of might, spirit of power, the spirit of knowledge, of understanding. And Lord, we just pray that you help our decisions, Lord. Help our decisions align with your will and not the will of the enemy. We just pray, Lord, that you help me make the right decisions in this project. Help me glorify your name rather than causing shame to your name. Help me just do the right thing in everything that I do, Lord God. And Lord, we just pray if there's anyone struggling in their life, anyone going through some difficulties, Lord, we pray that you attend to their situation, send the right people into their lives, and help them get out of that sticky situation. If there's anyone going through hard time finding a job, Lord, we pray that you find them that right job, and not let them get the job that the enemy wants them to get. Help them find that job where they can do their best work through. And if there's anyone struggling with their mental health or their mental well-being, Lord God, we just pray that you help them see, Lord, that the enemy is trying to take away their destiny and steal their destiny, and bring them to you, Lord God, and free them from those evil spirits. Thank you, Lord. We bless your holy name. In Jesus' name we pray. Amen. Cool. Amazing. Oh, that makes more sense to you now. Yeah, tree structures are like quite complicated, and the code, the code for that set function is like kind of big, and this is why I want to try and avoid calling it in a single threaded manner. So what I'm thinking about doing is in the generate, so we generate a bunch of voxels in that sort of array, the linear array, and what we can do, so I think we've got that sort of voxel model in it, I think it's called. Great, keyframes, one keyframe, because it supports animation, right? Now, we just do chunk voxel model ID. Okay, so we now can take this stuff here. Now, is this sort of voxel model init multi-threaded? Sorry, is it thread safe is the language I'm looking for. This is the light years hard in the gameplay programming probably because I don't know this low engine jargon. Maybe, not sure. So we with the gameplay programming, right? You still, you know, if you want to make things go fast, you still like, I guess, parallelize it, right? But yeah, I guess the engines these days sort of try and deal with that for you with like entity components and that, maybe, or maybe they don't. Yeah, I think the reason as well you have to think about it so much in this is because I'm trying to make a map generator that's like fast, right? Because one, if we want to like generate a new map, it would be cool if it generates quick as possible, so not like waiting ages. And two is obviously reduce the load times. And so yeah, we've got to think about these ways we can cut it down and do it proper, really. But yeah, and also there's just so much data to be generated. How do we even determine? Well, it's just, you know, practice and understanding like how things work, and you know, just thinking things through, and just have done it in the past as well and bumped into similar problems. You know, it's just lots of trial and error, and research and things like that. And you just pick it up eventually, really. These days, I guess you've got AI, so you can help it find different solutions, even if it doesn't find you correct solutions or ones which like are the best. It can at least help you think in different ways, which you can then go further with. So these days there's much. I guess before you'd have to search through like presentations, um, different videos on YouTube, different comments on forums, or whatever, right? Or work colleagues if you had that benefit, that luxury. But yeah, so it's just trial and error, really, and lots of practice. That's all I can say, and having different mental models that you've already wrestled with, like yeah. For example, object pooling is a method designed to prevent to constant process of allocating and deallocating memory. Yeah. Which is an optimization for games requiring lots of things to be used. No predictable enemies. Besides that, multi-threading is what making you move faster. Besides. Oh, so you're talking about object pooling as an example, right? And then you're saying so besides multi-threading. Nah. Yeah, multi-threading is definitely optimization in this case. But there's plenty of other optimizations which gone into this map. Stuff is like fitting stuff into cache and ordering the memory in certain ways. So yeah. Yeah, it's quite a big topic, some of the stuff. But in this particular case, it is just the fact that you was going to have one person, right, one thread doing 8 jobs, which took a certain amount of time, which is already long enough. And the thing is, you can split it between 8 people, right? So it is multi-threading is just going to bring the wins. Yeah, at this point. Right, so there is some kind of lock here on the object pool. So yeah, it's looking good. And this has got a lock on there as well. So it looks pretty thread safe to me. So I'm happy about that. So all we got to do is get the keyframe that we just allocated and get into the chunks. So you say chunk. Yeah, do you not do anything about the error? So what we could do is make that a separate job considering it can fail, right? Or you have a state that you skip the previous state on. So, if you get out of memory, you can do an counter and keep going, basically. I think that's sensible. But, so chunks generated. Yeah, that's right. So yeah, we could just make another bit set. You have to fetch it off there and do the store. It would be good to time it probably as well, how long it takes. Could do that. So, or I could introduce a state where you say get your chunk state, but so those allocated. So allocates it there to generate. And then you say generated. And then you say stored. Chunk model ready. Right. And those would be the stages you go through. So Yeah, so probably another one. So that's the generate job. Oh, so chunk model store. And right, so we can get rid of this then from here. So it's either goes into generated or nothing was ever set. So it does chunks. It unallocates the chunk. So it can be used again by the job thread. So model store is going to grab from the, probably wants to do a similar thing this one was doing. Do this least set bit thing. I was already kind of doing it. So yeah, go get the generated array and don't do the not, get the least set bit and it out of there and not and there that goes. Is it CPU, GPU, or RAM that get this generated map? I don't know. We have different things like VRAM. Yeah, so what's going on is purely done on the CPU. We're using a job system, and currently we're not using SIMD, but we'll be using SIMD at some point by using the ISPC compiler. So we'll be able to write like shader code, and that will allow it to kind of get an additional kind of pseudo multi-threading as well. So basically, if you're familiar with how like shaders work, and SIMD basically is, it runs the same instruction based on however many lanes it's got in the register. So on shaders, it's got like 32 lanes in a register, and they're kind of threads that run in lockstep. So every instruction gets sort of done across 8 lanes. So you can sort of get this sort of like pseudo threading on like a single core, and that's what we'll be doing for some of the map generation by using ISPC. So shaders do that automatically, and that's why they can do tons of pixels like really quickly, along with other reasons. But one of the reasons is all of your code in shader code is basically compiled into this sort of SIMD stuff automatically, so it makes it like stupidly quick. But yeah, on the CPUs you only have like 8 wired, I think. Yeah, AVX2 is just 8 wired rather than 32 wired. So even though we'll have like 8 threads running in parallel, those threads themselves will be running 8 kind of threads in lockstep inside. So it'll be kind of quicker that way too. Yeah. Yeah, it's kind of nuts really, the GPU stuff. It's just, yeah. Like it's just so much nicer on yeah. It's kind of nice on GPU the way it works, but also you have to dispatch it all from the CPU side and use Vulkan, and it's like super long. Whenever you want to do anything new on GPU, you have to like, it's a lot more work. But it's good fun. Right, so we just get the chunk that we want to that's been generated. So now we can just store it into the model and they're going to be in parallel. So we make that new model. We get the chunk way up, boy. This is my guy. Okay, so yeah, it's a real bugger. I've heard good things about, you know, like Nvidia's CUDA cores or whatever. Sorry, CUDA API or whatever, but it's kind of vendor locked. Right, so we could initialize this now. And then, you know, we're better off initializing it here when it's been generated. Yes. So that way we don't have to, if it fails, we don't have to keep coming back into here. So we can say it's been deferred maybe? No, not deferred. Well, so you get the chunk. Yep, get the keyframe and do the area store. So just able to store that quite easily. Then if you get out of memory and just say it's finished, and we won't always try to take it, isn't it? Yeah, so if you get an out of memory error, we'll store the bit back in there that it needs to be well, yeah, all the bit back in there that needs to be generated again. Yep. Process the unfinished chunk next frame. So put the chunk back on there. If not, we want to progress it to model ready, I think it is, bit set. So we should probably do the other way around. Right, you put the one which is going to happen the most first. So it's probably going to be fine most of the time. Yeah, the thing is people don't really enjoy it, but what people enjoy is the result, right? They enjoy the pixels on the screen and the thrill of being the one who put the pixels there, you know. And yeah, right, so that'll work. So that will make it parallelized. So then this voxel model store chunks thing, it's just the big boy model. This one is going to take it from the model ready bit set. And yeah, but how do we know they're all done? There's only 8 or so chunks. Unless what we do is make kind of a queue thing. Because like you can have a big old map at some point. Like we should probably move up to like 1,000 cubed. And do that. But some of them are also going to be missing as well. But yeah, so say we have the chunk size at 256, right? So that's the size of the width or whatever of the map. That's 64, right? So, and that's the other edge, that's the height of the map. So that would be 16, right? So 64 times 64 times 16. Right, so 65,000 models. That's quite a lot of models. I don't have the capacity to store 65,000 models. But yeah, I think what we should be doing is generating. Yeah, so I was thinking about making a model maybe See, 4,000 is too much. Was it 4,000? What was the number in the end? Yes, pulls up to 4K. I was thinking about doing a 4K model cubed. So that'd be 16 times 16 times 16. There's only 4,000 models. But yeah, if you just maybe, yeah, but 4,000 models that also potentially don't exist. What's the maximum number of models we support? Yes, it's a known that it's sufficient, that's right. Yeah, plenty. Plenty. Right, I think that's the way we should do it. So, yeah, we'll probably have to make another kind of concept other than a chunk, maybe something else. Like a region or whatever you want to call it. And I think maybe I was thinking about doing 1,000. 1,000 by because that way you could load them in. Yeah, maybe we'll... I don't think that matters just yet. Maybe it does. So what chunk, which is 256 cubed. The next size up is something we're trying to sort of fit it into. Whatever that thing is, and I'm thinking about saving that thing out to disk. But I don't want to call it a chunk. Should probably just call it a region or something. But so obviously, if it's 1024, that's 4 times 4 times 4, which is 64, right? So 64 different models. So we could probably make one of those things, whatever that is. That seems like a good idea. So we call it a chunk and probably call it a region. Chunks are just there in the generation side of things. Regions are actually stored out to disk and loaded in, and they're a single model. So you can probably list a region, it has this. And as you're making... All right, region model ID. Right, so put it there. So region, and then you probably want to have it sort of min coordinate or something like that. And the size of a region will probably be fixed. Now this sort of map gen chunks or whatever, that is probably just defined based on the number of threads that we have available. Maybe take away one. And Right, so we can then just say region model create or something like that. Maybe just call it stitch because it's just stitching. Stitch chunks. So the chunks that need to go, I guess you can have them here. You probably just want to have, you probably get rid of this number. And you probably have another one called like region chunks count. And so that'll just be, you know, one divided by the other basically. Also, you could just call it, say 64, right? But anyway, there we go. Then this can go here, where we have an array of all those chunk voxel model IDs. And that'll be done in a particular order, which will just work out probably Morton Swizzled again. So this region thing can just go here. And yes, the regions chunk mod. Yeah, okay, this makes sense, right? We could maybe also pre-calculate. I think maybe you can make it the index from this one. Yeah, this voxel chord. Yeah, you probably worked that one out. That seems pretty sensible. The chunks generated count capacity. Well, the capacity is just the number of these guys, but you know, it's in one region at the moment, but there will be many regions. But every time you make a region, you probably save it out to disk. And then maybe you load your regions in later on when you generate. So we'll probably generate the terrain in the first pass and just save it all out to disk. And then maybe pull them in again and sort of add in all the stuff which goes across the region boundaries, like buildings or something like that, and trees. Maybe trees go in here, I'm not sure, we'll see. Yeah. Yeah, I think this is fine the way it works, because we can derive when we skip to the next region based on the count anyway, because we get the chunk position from that as well anyway. Cool, I think this is good. So, perfect. So if we go to game, already in game, aren't we? Right, so we see here in this sort of chunk generate, I think let's make it such that it only just generates on the Y. So if it's not going to go down to the ground again and then do the removed voxels thing. We're getting rid of that code. We only did it so we can test test the code out and then use it for the voxel importer from other programs to remove the buried voxels, but we're not doing it anymore that way. It'll be part of the map generation code. So we're just going to restore this back to what it was before. It's just a very simple map gen. So CY is so chunk Y is Y take map chunk min Y. Perfect. There you go. Cool. Right, what's next? So how it works, so does this sort of like fetch add, and it's able to work out like the chunk generated count. So this is the map chunk index. We could probably take that map chunk index and turn that into some kind of like region chunk index as well. So it's able to work out from there the what's this doing? Why is it just doing the XY? Oh, because the flattening thing. Yeah, this should really be more than swizzle. This is not good. We can't really do that, can we? Yeah. So it's got to be more than swizzled within a region. So I got that block. Morton. Coord from block Morton. This is our guy. So map chunk index. The chunk dim. Dimensions of the map. World map. Dims. Yeah, I feel like this map generation shouldn't really be going inside the game anywhere. It should probably be its own isolated thing. And you should probably tell it kind of what you want, right? So you could probably say, yeah, we should probably have the whole dims of the map here. Probably have a much better API, probably, you know, some kind of like public API or whatever. Probably have, we could probably put this inside the Voxel. Yeah, probably put it inside the Voxel module, maybe. Probably with configurable region and chunk sizes. Or your region might just be, you probably defined the chunk size and the region is 4 times that, maybe. Something like that. Because we're going to be having a block map, which is, so this here is a 4x4x4, and this 4x4x4 is inside another 4x4x4. So that's 16 by 16 by 16. That right there, the 16 by 16 is what we'll call a block. And there'll be a block map where that is the smallest unit. And we want to generate those as well. So it's 1/16 of the size. Of the overall map. So that'll be 16 the chunk could be, and then that'll be but 64 by 64 by 64, is it really worth saving that to a file? Maybe. Yeah, it could be streamed in like the other one. Yeah, it could be possible. Yeah, I think let's massage this into the voxel system. I think that would be cool. Because it's kind of overlapping, it's kind of accidentally pulling from stuff in the game, which probably is not that great. So let's call it the map generator. You probably have some kind of spec or something. So rather than game map gen, you can just say voxel map gen. Then this would be some kind of like spec. So when you're trying to sort of issue some map to be generated, you say, right, I want the map is this big. I want it to go in. So I want the. You could probably give it some kind of like name, because it's ultimately going to be saved out to some kind of like file. Maybe it's called string it. But yeah, it's going to be saved out to like somewhere on disk basically, so you can stream it in and all that, right? So there's that. And you'll probably have a region size which has to be divisible by 4, so you can, and that'll be the chunk size that you generate things in. So something like that. So a region dim, and that'll be the size on disk. Those will be the individual units on disk that you'll save out and load in, and those will be compressed as well. So yeah. And then you'll probably have some kind of function where it's like basically generate me terrain at this place. Like, you know, so voxel map gen terrain at, and you'll probably have it be something like, you know, you could have your you know, your user data, right, your argument that gets passed through, or user data, but you also obviously have like the coordinate in the map, right? And you'll probably return some kind of voxel material index, because that's the bit that gets stuffed into the actual model itself, right? It's that U16 basically. Now, that will just be here, the sort of terrain at. There's a generator or gen terrain at, or I don't know. You can call it generate at, but it's just the terrain, isn't it, really? And there's the user data. This would be pretty cool if it's isolated, because I'm going to be having kind of two things which get made, right? There's the block map, and then there's the actual voxel map underneath, which takes the block map, which defines like a bunch of types. So each block, like, hey, this is a piece of dirt. You know, this 16 by 16 is dirt. This 16 by 16 here is stone. So when we do the voxels underneath, it's kind of some interpolation of the types around it, right? And it does probably some kind of like smoothing in some way. So if we have something like that, that would be cool. So the map gem will save that to some kind of place on disk. And you won't really get a voxel model itself back out. Yeah, I wonder what happens then, how you do things like structures and stuff like that. But I guess if we just start with the terrain, obviously, and make it multi-purpose, the same code can be used for two different kind of ways of generating. Then we can add bits like structures, like, you know, houses and buildings and whatever. Put those into the map as well. Those will span across regions, but we'll just start with terrain for now. So if we, right, that's good, I like that. These are kind of internal things. Really, this should be, these are all internal, you see. These can just go. We can work that out at runtime. Chunks count. In the region, right? How many chunks are there? Cool. So we take these and move them into like an internal side of things. So voxel internal. I'm glad we get to put this inside this sort of voxel module. So it's not necessarily like kind of belonging to the game kind of thing. It's kind of its own thing outside of the game. Let's just call that a map generator. Cool. So the function we'll obviously have is something like voxel map gen in it. Now you probably have it. Map gen dispatch. So you can dispatch some kind of just call it dispatch, right? What are we dispatching? Like that. Very nice. So we'll probably store this, go to the internal. We'll probably store it inside here. Now we'll get the bits out that we need. So there's a name, there's a region dim, dims and all that. The region dim will go in here. From that we can work out the chunk dim as well. Chunk dim could probably be outside. The dims, the map. Cool, happy about that. Super good. Cool. So I'm not really sure about how we do these allocations and things, right? Like, when you do a dispatch, you got to make sure you're not already dispatching, right? So probably have another Boolean flying around, like, let's have some flags or something, might as well. So we probably have some flags where we just say voxel map gen is running. And, you know, is, you probably only have one store job, isn't it? Is stitching. Okay. So we'll have these stored instead of just a bunch of booleans. There's all these U8 bit sets everywhere. This is a bit silly, to be honest. Not a big fan of these. Okay. So these U8s can just go at the bottom. Probably order this a bit better, but get the pointers near the top. Bit better. You know, this region structure is a bit kind of pointless because it's already instanced in any way. And it's just making us make more padding between things ultimately, I think. Or it might not, but... So perhaps we just do this and bring them out. It's not the end of the world. Just distribute those things about as well, so... So the region... chunk of voxel model IDs. Those just stay there. These are all a bunch of U32s, so they can sort of just stick somewhere around here. And voila. Right, so we need some kind of like... Right, it's this sort of game map thing. We just change that, obviously, as voxel map gen. And we need probably some kind of like initialize function, which will be called internally when the voxel cache system gets initialized. So yeah, I don't know what we could probably specify like, hey, what's the maximum number of chunks you'll ever need or whatever, right? Yeah, what's the sort of... We probably have a spec that gets passed in. And that'll say like, what's the... Um... Hmm. So chunk dim gets passed in. That's in a dispatch. Yeah, it's probably just say, you know, what is the chunk dim max, right? It's the maximum chunk dim you can have. And again, we'll probably have to just store that in here. So that's what we've allocated with. So all these sort of chunks here, those will have their voxels allocated with chunk dim max cubed. And then we probably want to specify like, hey, how many sort of threads do you want to use? But then also at the same time, we could probably just like, you probably just want to max. So this sort of chunks here. There should probably be a chunks generated. Yeah, region chunks count. Maybe that can always be fixed. It being 64. Right, so a chunk is like, so yeah, region dim and a chunk would just be 4 divided by 4. So maybe get rid of chunk dim as well. We just worked that out. So you could probably just pass in implementing that now. That should be a lot better. So we get to the game. We've kind of written most of this in here. Let's find the generator. Let's just delete this from existence. It's no longer in the game strut. So we're going to put it in internal. We'll go here, voxel map gen, like so. Now, we go to game.c and we simply find this section here. And we'll just take it over to the new place. These are just a bunch of threads at the moment. So voxel.c, so I think it was under model, under accessor, under this stuff. It's above the cache, basically. Alright. Now, we've got to change some of these things where they say capital G game. We've got to do, replace it with voxel. Anything is just game underscore, we could probably do voxel map underscore. We'll see these log tags, but we'll sort that out. Anyway. And then lowercase game underscore. So we go to voxel internal. Cool. I'll sort it out there, and that one's a region. This is the new name for it. Okay, so voxel.h. So we should probably have a dispatch, and we also should probably have some kind of like, let's call it tick, right? It's kind of like update kind of thing. Or maybe call it kind of like, yeah, maybe update's just fine. It's like, I'm not usually a fan of the word update because it's kind of doesn't really describe too much of what it actually does, but it's kind of like maybe it's kind of like checking the status and then possibly launching more jobs, right? So probably just call it update for now. Just live with that. So let's get these two guys. If I can think of a better name, we'll just change it later, right? And let's go back to the internal. There's also an initialize board down here. So if we go to voxel.h, we should be able to find this sort of spec here. And essentially we just pass in the sort of region dim max. So that we can pass into here, voxel map gen init, and then it's something like that. Okay. Cool. So for a dispatch, you probably would assert, you know, do an assert just to make sure that so you probably would just get the map gen like so. So rather than g game, you do g voxel cache. That's the way you'll roll. So get yourself the map gen and say right, map gen flags and voxel map gen flags is running. So we want to make sure it's not running. So you probably need a way to know whether or not. Yeah, we also need to know when the job is kind of done somehow. So you could probably just have like a U64 and just be like, hey, you know, this is the your dispatch job ID or whatever, and obviously we just tick that number up and you just increment that number when it's done and just check if it's greater than, and then that's the comparison. So that would probably be the easiest thing to do, but I was just thinking, yeah, okay, that's probably fine. Hey Strival, just finished watching GTA trailer. Fair enough. What is there a new one? Already E32 is probably fine. You won't generate more than that. Just let's wrap the strut or something. But yeah, probably have it as a get some kind of like map gen. Yeah, it's called fair play. Yeah. They have spent a long time on it. You know, should, you know, look good, I guess. But yeah, I wouldn't obviously be playing it. But yeah, there's not much, you know, stuff you can do in there without sinning, basically. Voxel map gen, dispatch. Give back a dispatch ID and say what is done. You can probably ask if a particular dispatch is done, and then say if it's running already as well as another one. That would probably be sensible. If you see like in Red Dead Redemption, the latest one, they I th- I think they did a lot of again I haven't played the game, but I remember seeing they did like Red Dead Redemption 2, so I guess you'd say RDR2. They did like this volumetric cloud stuff. I don't know if you've seen that. Yeah, they've already kind of, since the last GTA, made this game. This game probably did like lots of they've already done kind of lots of crazy graphic stuff on this already. Oh, for crying out loud. Got it. Then we're gonna get really good quality. Apparently it's meant to be in 1080, but we'll see. It's kind of crap. It's very impressed. But they like fly it up into the skies, and it's this big old. Come on, this is horrible. I have got YouTube Premium, but I'm not signed in. I know that's the reason why they're taking so long about it. But yeah, you don't even get a chance to fly up in the game, but they've done that volumetric clouds and things. But yes, they've already made this game look kind of cool. So yeah, I would imagine the latest GTA is going to probably look even better. But yeah, spent a lot of time, a lot of people, a lot of money. All right, go in. So we could probably just. So, cannot dispatch another map gen. While another is already running. Cool. So we can dispatch obviously just all those bits on there and voila. And you want to make sure you sort of set up, you copy over the right parameters and all that. So mgd and like that. Okay. Cool. That's a good first step. Maybe. So is it done? Well, we'll just tick a thing when it's done. So we'll just have like, oh, you want to return like an ID, right? So map gen, you could probably call it like a dispatch ID or something like that. So you could probably start this off on a dispatch index, do a +1, and then down here you can do a plus equal 1. And then something like that. If it's done, of a U32 dotting around in here. Dispatch index. So an ID is 1 plus an index, right? And then, oh, it's got to be a Boolean, obviously. So you'll just return ID raw take one would be yeah, I wonder if I might as well. Yeah, okay, I've done that. So that'll be if it's less than, then yeah, it's obviously finished. Cool. So this update thing, you know, we had this sort of like dispatch code in the game, so just got to go and bring that in here now. So this is basically it. It's the update code. Got to change it a little bit, but it's basically there. So every frame, it just sort of checks what needs to be done and then does more work, right? Sorry, dispatches more work off on the job system, off on the thread pool. So there is some kind of new flag thing, stitching. It shouldn't be one stitcher per. To be honest, the stitcher shouldn't even be a separate job, maybe, because you're just literally. It can literally just happen. Yeah, why am I dispatching another job to do that? It just seems a bit like it's doing one allocation. Well, yeah, it means that other stuff can just happen. But when the stitching is done, that will get you another region, and then you can save it out, basically. So you could probably call it region save, right? Save to disk probably is probably the better name for it. So yeah, you can probably say is storing, probably a better name. Okay, so you probably say like is storing region. So we probably want a way of like saying so the chunk's been generated. You want to know how many. So you want to call this like chunks to generate count. Chunks to store. I'll call it model store or something. Chunks to model store. All the ones which have been generated. Probably opposite of that number in it, really, but this sort of min thing. So no, not of the bits. And then there'll be this one here, this bit set here. Where's the model ready bit set? Now, oh, what's going on there? In red are my numbers. saying the stream seems to be running. It says offline on Twitch though. Let's check on my phone. It says I'm offline, but also says I'm online. Weird. Okay, it's running. Weird. Okay. Let's see if it's working for you guys. Anywho. Yes, we don't want to keep... It's not very good. So we want a problem where if we run it one frame, it will kick off the ones to store into the model. But if they're not done yet, it's going to kick off even more, right? So I think we want to keep track of like how many jobs we've got running in each. So that'll be a voxel internal, probably get rid of this one. Yeah, so 3 different types of jobs basically. So I think we want to say, right, probably just be U16s, but so we've got this sort of like chunk generate. Now, jobs running, right. Chunk generate, jobs running, chunk model store, jobs running, and region. For the region stitching, it's not really called region stitching, it should be called storing region. Yep. This is better. So yeah, how do we know how many sort of threads do we have? Chunk generate jobs running. So we should probably get that sort of number, right? Like an atomic load. And essentially, we don't want to kick off any more than we have sort of remaining, right? So remaining jobs to run. It's probably something like that. So that will then mean we probably need some kind of like, hey, what's the number of like threads or something that you're gonna so the chunk generate jobs you want to be running at most is the number of bits that you have there probably. Chunk model store. I don't know. Do we need to do that or not? So the whole point of the thread pool is that you can just give it some jobs and it'll do them. It's just so yeah, we just want to launch as many as we can do to do a region, right? I think that's basically it. You just launch. Yeah, we get rid of that. It's not a good idea. So we have a region which has up to 64, and you want to have chunks generated count, right? And you launch as many as it does to get to the next region. When the region is done, you store. Yeah, I think that's the way we do it. So these are fine. And remaining chunks count. Now I'm just thinking, so when this is like a multiple of the 64, you got two things, right? It's either done or we need to sort of start the process off for it to try and save it, basically. So I guess that's what this sort of is storing region thing is about, right? So if this is a multiple of, oh, sorry, if this is a multiple of that, we're either going to be storing or we're waiting for it to be stored. So it's not equal, this is the main path. Else it's the other path. So this path is where it keeps dispatching jobs. And then the other one, it can do the dispatch another job just to sort of do the saving. So remaining chunks count is to capacity. That's really a big no. but you probably want to say the next end, so that would be round up to multiple, so this to the next multiple of, man, not sure what's going on with Twitch today. Man, Twitch is seeming busted. Hopefully this recording will be alright. It's live streaming just fine on YouTube. Oh, yeah, Twitch is having a bit of a problem. Okay, that's fine. So anyway, round up to nearest multiple of this thing. And so remaining chunks count, chunks to generate, chunks to store. So we can get rid of this. So the number of jobs that we need to launch is this plus this. Oh, sorry. It's convert them to Boolean, added together, because we've got a dispatch count, which is great on each job. So we can launch the same job many times, just by keying one job. They're super powerful. So if you have chunks to generate, you launch this job here. Then if you have your chunks to store, cool. So the out of memory counter, yeah, you probably mark the dispatch as a failure or something and get a result back, maybe. I don't know. There's something to think about. How do we handle that? But yeah, so the other one is like if it's a multiple, you want to kick off a job. So if flags and voxel map gen flags, there's sort of is storing, is not storing. So if it's not storing, kick it off, make a job. This will be one job. And all your flags on there. And that'll be the final job here, which is going to ultimately do the storing into the file. Got to clean that code up a little bit, but we'll call it a region. What does it call that? Store file? What do I call it in the end? Model store. Store to disk. That's the ultimate plan for that one. Don't know if it's going to be compressed, but it's definitely going to be stored to disk. Right, so if it's not storing, marker is being stored, one job. Then uh, so one job. Nice. Cool. Oh, it's working. Thank you for posting. That's great. Just the Twitch has been really weird on here. The panels not displaying. It was displaying in red, and the numbers were going all weird as well. Thank you. Okay, so is the update function mostly done? Obviously, it's not completely done. There's still issues, but that's pretty reasonable. So initialize at this point. And probably store the right. We're gonna store that in there. That's for sure. Because otherwise, and we're gonna probably assert to say if you ever do a different region dim size, then clearly region dim max. If that is different, if that is less than, so it's got to be greater than or equal to. So cannot dispatch. Ah, the chat is coming back now on Twitch. They're slowly fixing it. Cannot dispatch region dims dim this when the voxel cache spec region dim is less. You just pass in your two values. Like so, okay. Cool, that's a good check. So you need to do like all your allocations, right? So your sort of chunk dim max is just this divided by the node dim, or whatever you call it, voxel model node dim. So it's just 4 basically, divided by 4. And it's got to be divisible by 4. Cache spec dot this must be a multiple of this. Okay. And then cool, so you can do all your allocations now. Yeah, I guess we could just do 8 chunks, or... Yeah, it would be nice to scale to people's CPUs, right? Because don't do that, we're kind of failing. Now, maybe we can just do at most 64. Although if someone has more than 64 threads, like... Yeah, at most we could probably go up to 64 anyway. Because that's what the map is, right? The region is... Yeah, it's a 4x4x4. Okay, so those are your units you generate in. So... Cool. So the chunks you make... You just allocate that here. mg chunks equal core alloc array voxel gen map or map gen chunk. So the allocator would just be the static one. And voila. And each chunk, so you just go over all the chunks. There will be a voxels array. You just do a similar thing. There'll be a voxel material. And that'll be chunk dim cubed. So, cool. And so that should be the allocation sorted out, I think, pretty sure. Now, right, so let's take a look at this stuff now. So, what will be great, so this is the generate job. It takes the next chunk index off there to generate. And that'll need to be U64s now. Good. Now, you work out what map chunk index it is. You work out, great, this is the whole reason why we end up doing this kind of refactor, is because it was reaching into the game's world state. Bad idea. So we've separated out into its own sort of system now. That's cool. So it'll be mg dims, right? So it's the map dimensions that we're trying to generate based on the dispatch that we kick off. And we're doing some kind of like... No, we don't need that. This lovely little Morton swizzle. I think you used to do the... So, oh yeah, we need to make sure that it's a power of 4 as well. Something like that. Yeah, how do you know if it's a power of 4? Whereas a V and -1. Yeah, it's pretty clever. So right, so how would you know? Yes, how would you know something is a power of 4? Um, right, let's just use AI for this guy. C, check if value is power of 4. I wonder if you could. Oh, that's interesting. Oh, you do count trading zeros as well. Yeah, I don't want to do that. Why would you use an instruction like that if you could just do it like that? Yeah, that kind of sucks because it's not type independent. Unless, well, it kind of is. No. Oh, I see. So it's ensuring that. Oh, okay, it's pretty clever. I want to make it type independent at all. Don't use generic. Fine. Yeah, I think we'll just. Yeah, so it's just ending it with like 5s basically all the way. I equals 0, fair play. So I guess we'll just do 32 on the end. So, and V and this. Gotcha. Not equal to 0. Cool. So that'll be 2, 4. Now we need to do the assertion basically. Must be a power of 4. Cool, that'd be nice. So in the here. Yeah, I could have just ran up there as power of 4, but that's not good, right? They should do it. So if it's power 4, it's definitely multiple of that. Nice. Well, yeah, anyway. We'll keep them both. So the other thing I want to make sure is power 4 as well is when you do the dispatch, that again, this guy. Cool. Right, it's a good check. Very, very good. Right, just take a quick break and then we'll carry on refactoring this. So this job is going to basically call out to a function pointer to the generator inside the game and set up the chunk data accordingly. Yeah, right, BRB. Welcome back. Welcome back. Okay. So what we're carrying on doing. Okay, it's all good. I think so. Let's double check. Yep, it's all good. Lovely. Right, so what are we going to? So we were just been refactoring this and bringing it into the Voxel module. And we're in this sort of chunk generate job right now. And so this is just obviously thrown on the thread pool, picks up the next chunks we generated, and shall try and generate that chunk. So it adds one to get the map chunk index, so where it is inside the whole map. Here we can do some sort of Morton swizzling with inside the region maybe. So is there just a single dim? I think so. Good. So the dim would be, so it's got to be that'll be region dim. So it's got to be a power 2 because it's Morton swizzling. And all the chunks be done in a linear. It'll sweep across the map in a row major type order. So a typical image row then column kind of thing. But within each, we'll do that for each region in that way. So the regions will sweep over in that sort of linear fashion. But within the region, will be Morton swizzled. So all the Z ordering perfectly. That's what this function will do. So that will be, so this will get us the yeah. It's not really right, is it? But yeah, you want to do chunk index multiplied by the number of chunks in a region. Multiplied by the number of voxels in a chunk, probably. Nah, you should probably have it Morton swizzled within the chunk. That would be better. And so that means then the chunk index multiplied by the cube of chunk dim. Yep. So that will get you some base coordinate of where the chunk is going to be. So that'll be a sort of a voxel coord min for a chunk. So the Cool. We'll call it voxels per chunk. Chunk voxels count. So you're going to want all the elements. So it's all invalid. And then you want to call out to the map generator callback function thing. So that would be generate terrain at so I wonder if you just let the user do it. You give them the chunk. I wonder why you need to use this function anyway. It could be quite easy. I think what we had before was better. We'll find what that was now. Where is it gone? Fine. Yeah, this is a bit too complicated. Yes, so we just want to do the sort of unflattened thing, I think. Before. So map chunk dims. Divide roundup. The map dims x by the size of a chunk, so chunk dim. Right, so there's a chunk award. Should be it. Yep. But that'll be a more efficient way of doing it. Okay, so this generate terrain, you should probably just call it generate chunk and just pass in the stuff you need. The generate chunk, this is the callback. We could, you probably pass in the voxels. So these will have to be like swizzled in there basically using more swizzle. So what I'm doing. Chunk voxels, and then the chunk voxel chord min. And the dim should probably be passed in as well, maybe. Might be useful. Yeah, that'll be it. So this way, this can be put into a function now here. So game map generate chunk, whatever we'll call it. You get your voxels, your DST material. There's more swizzled into there. You'll get your voxel chord min and your chunk dim. So that'll be super powerful. You can take that, put that in the game side again. Put it somewhere. It's got to find where to throw it. Probably make a new section called map or something. More in world. Anyway. Yeah, let's pop it in here. Change it up in a bit. But there we go. So that's our simple generate function. It just generates this sort of sine wave hills and valleys. But this will be much better later on. So let's call it DST. And do the more on swizzle. And voila. So we probably want to return some kind of boolean, whether or not you actually set anything. So you should keep that state and return whether or not if it has set. So inside the voxel thing, you just say, so if it's set anything, if it has, it's been generated, so we mark it, if not, ungenerated. Nice. Now I've got to be careful here because it's a U64, so we should really be casting this to U64 and doing the shift, because if not, it's gonna be a U32 and then not work. Right, so where are some more one shift lefters? Right, I think that's all back in business. Right, so that's the generate function done. So now this is kind of some reusable function in a way, right? It can be used with different types of map generators, which we're going to be doing. So that's the reason why we've done it. That's pretty cool. So we've got to change the header. So rather than being a terrain, it's going to be sort of a gen chunk. Map generate. Let gen chunk function. That's be good enough. So much better. Right, gen chunk. Oh, cool. There we go. So it's already passing some kind of user data. Might be useful. Might not be. Yeah, I typically don't need user data because I use global variables. Yeah. So that'll be mg. Nice. Cool. Right, so I'm happy with that. That's super great. So the next thing is after you generate your chunk, again across multiple threads. So an example 256 cubed, we want to then try and store it into a model in parallel as well. So you take, yeah, it would be nice to kind of dispatch that right away, not gonna lie, but hey ho. Should be fine. So you take it off the array, sorry, off the bit set. You check the generate bit set instead, because it's being generated, so you get the chunk. You just store it in there. We've got to get that chunk dim. We just store it in there. Ooh, not at an offset though. That is wrong. Oh, have we not made a chunk yet? Hang on. 2 seconds. Sorry, a keyframe. It needs to be like a keyframe initialized, right? How do we set up the keyframes? This guy. So we also don't know what the thing is going to be using, but I guess we can just assume it's a U16, but we could change that if later if need be. But yeah, so keyframe in it. So it's just chunk dim. We want that when you make the model. To get the keyframe. To get the keyframe, initialize the keyframe. Cool, so this one then just gets it, makes an accessor, and just takes the area, the linear area, and stores it inside the tree. And then oh, that's very powerful. So it's a Voxel internal. Well, the model ID is sitting in here. So realistically, that regions chunks count can go. Realistically, you could Just go here and just call it chunk. Like these. And that's what you'll be using instead. So when you allocate this, so there'll be a linear set of, now you just got to figure out like, how pull out Voxel melodies, I think. Cool. Yeah, so we've got to make sure we set them in the right order. So they've got to be Morton swizzled. So if you've been given, yeah, you can probably mark it right away as model ready bit set. That's what you want to do. You want to mark it. It's ready to be used in the, to be saved out to disk basically. So you'd say or. So now the question is, right, how do you work out, work out your sort of region chunk index? It's a bit different because it's Morton swizzled. So it's a 3D 4x4x4 Morton swizzled. So given your regular chunk index in a linear fashion, maybe, how would you do that? Yeah, this has worked out that sort of chunk index where it is. Yeah, I think you want this to be working based on region. So how many regions across the X and Y basically. And then given your chunk index multiplied by how many chunks in a region. Is that right? That'll give you like a region coordinate basically. Or I'm looking at divide. I'm looking at divide, right? Yeah, but you already know the region coordinate anyway. So why am I trying to do this? Yes, you already know the region coordinate. It's here or something. Where is that? This one. So get rid of all that. We can then use the Morton. So we can work out. So you mod 60 for it. That gets you your region. Alright, here's what you do. So your region chunk index. So it's map chunk index mod region dim. Then Wait, sorry, not region dim. Really, 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 really wrong. Oh no. Number of chunks in a region. That's what I'm looking for. So it's mod 64 basically, right? Now, that we can turn into a... I got a special Morton code thing, so coord from Morton 64. So this is a special one where if you only have 64 values, you can do a smaller amount of work basically. But then again, my main one, yeah, it's just like one shift basically. Like one of these. And the compact is a lot, right, rather than doing these. So that'll be... That'll give you your chunk coordinate within a region. Within the local region, right? It's the local space one. Now, what can we do with this? Yeah, so with this we can generate... We just need to work out the map. Yep, so a lot of this just goes, these two. We'll be multiplying your chunk coordinate by the chunk dim, and then you add on the region chunk voxel, sorry, region voxel chord min. Right, so that gets where it is in the whole entire map grid, basically. Cool. And that'll be Morton swizzled and in the Morton order, so it respects the map, sorry, the voxel model tree, so we can stitch like all of these voxel model indices which we're about to sort out. So that'll be mg chunk voxel model IDs. When we just use a chunk index now, right, which is 0 to 64 or whatever, that will mean we can assert, no, you already said that, right? It's a U64 bit set thing. This will be in the Morton order, like the tree nodes are. So when we stitch 64, so a 4x4x4 set of voxel models together, they will be in a Morton swizzled order. That'd be cool. So you do a, I guess you could probably just get your, and then just plop that in there. I'm happy about that. That's really good. So now in the store job, so we're taking the chunk, which is a linear array, and just storing it directly into its own local voxel model. We can now use this array of model IDs and just use the chunk index to literally just get the right voxel model, and yeah, we just store it in there. We use a 0 offset because it's local to the actual model, the actual chunk. We just pass the chunk dim to say that's how big the area is. Everything's Morton swizzled, so we just throw it in there and it will be very efficient as it goes to set it through the tree. It will do it in a sort of a Z order rather than a row major order, be in a Z order. But yeah, just look at, if you don't understand it, it's called Morton code. Just research it up, you'll know exactly what it is after that. The Morton order is another way of saying it. So what else? Yeah, so that happens. So when this is done, right, so if it's an out of memory error, sorry, if it's not an out of memory error, we say, right, this is ready just to be thrown into the file now. If not, we up the im counter and just try and generate it again next frame. Cool. So, nice. So the final one is this store to disk. So it used to go through all of the chunks one by one, but now it's doing it in parallel. So you want to find... So now how do we know that it's okay to do it? I think is the thing, right? If they're all ready. So in the update, yeah, we only want to do the launch if we do a bit count of chunks model ready, right? So the models are ready to be thrown into the file. And if all of those are equal to the number of chunks in a region, right? And so that's only when you can say, right, it is storing to disk. Now, please dispatch that job. So it can happen in a background thread whilst other stuff can run for the game. So this can all basically go. I guess we can set aim counter to 0. I don't know. We've got to think of that aim counter thing, but right, so all this can go. And what you want to do is at the end of this, you want to set all of those things, you want to free all of them. Where is it? This sort of thing you want. At the end of everything, you kind of want to... Yeah, I think you want to remove the flag. No, I don't have an MG, a map generator. Voxel map gen. Okay, cool. So what is this doing? Well, we want to reuse some of this code, but not all of it. It was removing the buried voxels and was testing out that API, saving out to disk. We do want some of this, and we also want to put it into some functions as well, like this whole storing a file, right? So taking a map and storing it, but wait, what is this code meant to be doing? Model IDs, index, and we want to call this sort of like voxel model DNet. And yeah, that's the thing. I haven't really got... Yeah, this one actually wants to deinitialize it right away. So yeah, we'll just throw it in there and get rid of it because it's now been merged. But Also, we don't really want to do it that way. Yeah, this is interesting. But we don't want to deallocate all of them. What we want to do is like remove... Wait, this doesn't deallocate from the pool. Keyframes. Do 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 do. Okay, is it the third? Probably. Just say deferred, might as well. That ought to be good enough. But yeah, so I think, right, what we want to do is... We probably don't care about this. But we do care about these. So at the end... to disk, this job, the end. We probably want to do something like this. And you can store back in there like a null ID. Voxel model ID. Just a manual kind of deallocation thing. Yeah, that could probably come part of the merge code actually. We should probably have a function called yeah. Okay. Yeah, so we should probably wrap this into a function. That merges these models into a single one. But yeah, we want to be careful how much we generalize this. Right, we just want to make it probably say like, merge 64 or something like that. And it just merges 64, which should be in the right order and just does in a very quick way. And I don't know what we want to support keyframes either. Like more than one keyframe maybe. Probably not. Probably never use that. But yeah, probably just assume one keyframe. Just to make it easier. Yeah, we should do that. So yeah, good progress today. So what we've done is basically make this lovely little, in the Voxel system, we've put the map generator now. So it's a nice little API where we can like dispatch a new kind of map gen. It saves out to disk in a certain location and into these different files called, like a little, you define how big like a map region is. And that's a file each basically for each region. And a function to make the chunk, which is a quarter of a region in size, a quarter in each dimension. So there's 64 chunks within a region. Those all get made in parallel, and then they can get stitched up at the end and saved out to disk before the next region gets made. So yeah, it should be pretty powerful, and we can use it to generate different kinds of maps, which we will be. There'll be two kinds of maps. There'll be a block map, which will be a 16 by 16 by 16 voxel. Would just be, yeah, the 16 by 16 by 16 voxels that you see here, these sorts of 16s, would just have one kind of type. It would say like dirt or stone or something like that, right? And then the voxel map itself will look at the block map and essentially interpolate between the different block types and kind of fill in the higher detail, basically. So there'll be two kind of map generations, which will all be saved at the disk and streamed in and everything, because the block maps will still be used for also gameplay as well, to say like, hey, I'm standing on dirt, I'm standing on, you know, that sort of stuff, right? It'd be useful for gameplay too, and other things. But yeah. Right, so next stream will be tomorrow, actually. I'm going to have another stream at 2 p.m. GMT plus 1. There's also streams on Sunday, Tuesday, and Thursday at 7:30 p.m. GMT plus 1. You can check out the Discord where we can chat in the meantime. Yeah. You know, things are a bit uncertain at the moment. You know, my wife is pretty ripe at the moment. You know, she's the due date for this new baby is a week and a half away. It's on the 6th of September. So really, I could be taking a break at any time. So if I do disappear, I'll post on the Discord channel if the babies came. And I'll be gone for probably 2 weeks or something like that. And we'll come back and do the same. We'll carry on. So we're definitely going to take a pause in this whole map gen stuff. You know, because we're going to be generating a whole big old map, and it's going to probably take a lot longer than going up to not this Sunday, but Sunday after, and also the baby could come before. So there's that. And obviously, yeah. But yeah, I'll keep you guys posted as and when I know things. But yeah, there's the YouTube channel. You can watch there's a video on there describing the sort of game we're building and what we're building towards. And what else? Way to support the channel as well to get access to this code to run your own local machine and look through the code base and learn from it that way. Things like that. Yeah, thank you for everyone who supported the channel. I really appreciate you all. And man, I'm a tired man. But yeah, tomorrow I got the day off work. You know, it's my Fridays. Do some business stuff. So we'll be streaming 2 p.m. GMT. Oh, your message got censored. Where's that? I can't see it. Yeah, I did see your portfolio be posted. I did take a quick browse over. I think it's my lunchtime. It's a quick browse, but I can take a more in-depth one. Nah, I wasn't taken down by the. Oh, you sent it in there, right? Okay, with the auto mod, right? Yeah, I'll take a look on the Discord. We'll take a browse. Yeah, I'll maybe get some time tomorrow. You know, a bit more free time. Yeah, no worries. I'll give you some honest opinions. Don't worry. Yeah, that's cool. Yeah, I'll be honest, but also be nice at the same time. Don't worry. It's you know, it's really difficult sometimes. It's quite sad really as well. I've seen a few people have come by the Discord and they'll post stuff they're working on, be excited about it, And sometimes it hasn't necessarily been that good per se, or it's had problems, or they've been having problems and they want feedback or something like that, right? So um some other people have posted and given them feedback, and it's been in a in an okay way. But when they sort of take that feedback, they not very what's the way of saying it? Yeah, they get too hurt by it, and then probably want to stop programming altogether. I've seen in one case, which is quite sad. You just try and tell them that no, we all go through these stages or whatever, but there's been that one. And what's another one? Um, nah, it's all right. I won't be mean, but yeah, sometimes you're just trying to be honest, but also nice, and give someone like just be constructive, but also just say, I'm struggling with the same things and all this. But you're not trying to sort of ruin people's confidence or enthusiasm. But you're just trying to sort of correct, make sure, are you aware of this thing? And unfortunately, quite a lot of people take it the wrong way, which is a shame. I guess part of the reason why is it comes across in text form as well, and people just, you know. But yeah, no, I've definitely felt that way in the past as well. So, but hey ho, yeah, we do hate criticism. That's right. Especially when you read the Bible. I swear people don't like not reading the Bible, because you read something from there and you're like, I do these things, and it hurts sometimes. Yep. Yep, the Pharisees hated Jesus when he told them the truth. Yep. Yeah, Jesus told them plain and simple, you know, your father is the devil. Well, that's because yeah, there was reasons why. But yeah, I think it's Book of John does that. But you guys, if you don't know Jesus, it's a good time to know Jesus. Jesus can come at any moment. The world is going pretty crazy. He can come anytime. The the Book of Revelation is becoming more feasible to sort of implement it with technology. Like, oh, my program just crashed. That's not very nice. I was going to fly around while talking about the gospel. Yeah, the Book of Revelation is getting the mark of the beast, the image of the beast. Can be implemented with technology these days, or it's coming pretty close to be. So, Christ can come at any moment, and it could be fulfilled with technology and not just wave hands spiritually. So, take a look into the gospel. Give a serious look. Look at the evidence for Christ. He did really live. If you're an atheist, you probably follow, evolution and all this lot, and think, well, if his evolution is real, God won't be real. But have you seen the Shroud of Turin? Like, you call yourself men of sciences, but do you look at all the science? Because Shroud of Turin is pretty compelling, and it's literally the burial cloth of Jesus, resurrection, proof of the resurrection right in there. People want to just say, oh, it's been disproven, but it's not if you look at the actual science and looking deep enough, rather than just people saying things. Looks pretty compelling. Plenty of resources out there for that. Yeah, Christ did raise from the dead. He was resurrected. So it depends what you want to now think about that. Yeah, Christ was real. Is real. But in history, he did come and resurrect. But yeah, most people who believe in the science just want to believe what their people above them say, because it kind of feels like a religion, right? You trust what this scientist says or the group of scientists say, and what you have there is a religion. Take a look at the evidence yourself, and you'll find that the Bible has been preserved, you'll find that the Shroud of Turin looks like compelling evidence for the resurrection of Christ. You'll find that Christ did really live. Christ is the most documented individual, probably, I think. Definitely in terms of the ancient history, is, if you take a look at like Julius Caesar, compare Christ to Julius Caesar, Christ has so much more written stuff about him. Even his enemies wrote about him, you know. So definitely was real and definitely rose from the dead. Just take a look because, Christ can come anytime, the world could go crazy anytime, and it's much better if you know Jesus. Because Jesus came to save. When Jesus came the first time, he did not come to judge, he came to save. But when he comes the second time, he comes to judge. And he comes to judge based on whether or not you received his salvation, because man cannot go to heaven because man keeps failing. Man keeps falling short and sinning, and he needs a savior. Take criticism, well, just honestly, just from experience, Dev is all I want. Cool, no worries. Scientists once said, little science makes you believe there is no God, but a lot of science makes it undeniable there is a God. It's true though, isn't it? When you have the perspective that God is real, like when you look at everything, it's like, this just proves God is real, but yeah. There's so many things that point to God in nature. This world is way too finely tuned. Exactly, yeah. And also, like, discovery the discovery of what makes up a human being, like that each cell has like basically like a 4D printer for DNA. The proteins. Sorry, that takes the DNA and prints proteins like a 4D structure. It's pretty nuts. It's 3D, but it changes over time, right? And it's like a code, like a computer code, like it's been designed. So lots of stuff which point to a creator. And the world will probably try and sell you that it's probably aliens or something. That's the cop out. Rather saying there's a god. But yeah. Yeah, but anyways, I think I've got to get going now. But we could talk more gospel next stream. I'm too tired to present the gospel. But now we come from an ape who are fish who was a single cell. Yeah, I think you missed out that we also, in between the fish and the single cell, there was a mushroom as well along the way or something like that. But yeah, it's a bit sad. But I believe that too, right? I believe that too. So we've been there. But yeah, God bless you all. Have a good night. I'll hopefully see you tomorrow. Bye bye.